Good afternoon. We are going to study put call parity in today's class. Put call parity is the relationship among the call price, put price, stock price, and exercise price, or also we can say the risk-free rate of a risk-free rate and time to maturity of European call and European put. So let's move to the next slide. Put call. There is a special relationship between European put and European call with same underlying assets, expiration date, and strike price. The price of the European put and call on the same stock with identical exercise price and expiration date. That means same exercise price and same expiration date on a same on a same underlying assets, then this spatial relationship is expressed on a formula called put call parity. So put call parity, to derive the put call parity formula, we'll use two portfolio. For this, let's move to an empty slide. Let's move to an empty slide, and we'll consider two portfolio. Just a second. We'll consider two portfolio. Portfolio A and portfolio B. Let's say that this portfolio A consists of one put option, as we have mentioned earlier that this put option is European put, so we write European put with let's say the underlying assets is a stock with a price S naught, and it has time to maturity T, and the expiry the strike price is mentioned as X. Also consider that this put option consists of stock, sorry, this portfolio A consists of stock and whose value at present is noted with S naught. On the other hand, we have portfolio B that consists one call option, and this call option is a European call option, so the notation is C naught. Thus consists stock with this call option is for a stock with present value S naught and time to maturity T and strike price X. These two things for put option and call option, the time to maturity, strike price, and the underlying assets should be same for put call parity. Furthermore, consider that this call option also consists a zero coupon bond. Zero coupon bond. This zero coupon bond gives you gives its face value X face value which is equals to strike price at the end of the maturity T. So the present value of this zero coupon bond can be written as X by e to the power RT, or this is also equals to X e to the power minus RT. So we have these two portfolio A and portfolio B. Portfolio A consists of these two assets. They are one is put option and one is stock. Portfolio B consists two assets. One is call option and the next is zero coupon bond. So let's say at the maturity, the payoff from portfolio A, let's say portfolio A, and it consists of stock whose initial investment is S naught. The value of the stock will be ST, but we have to consider these things that for option, either this ST will be greater than X or this ST will be smaller than strike price X. So in this condition, we'll try to calculate the payoff. So the payoff from the stock will be ST in both cases, because it's not going to be affected by this exercise price. For put option, when ST is greater than exercise price, or when the exercise price is lower, when the exercise price is lower in put option, then you let the option to expire, so the payoff will be zero. In other cases, when the exercise price is greater, then this greater exercise price minus ST will be your payoff. In this scenario, the net payoff from this portfolio A will be ST or X. If ST is greater, if the stock price is greater, then the payoff will be the price of the value of the stock. If the exercise price is higher, then the payoff will be your the exercise price will be your payoff from the portfolio A. If we go to portfolio B, and if we absorb the payoff from this portfolio, then we have a call option and we have a zero coupon bond. Let's start from bond. The initial investment in this bond is X. The present value of bond is the initial investment, e to the power minus RT. So bond will give you the face value in both scenario. It's not going to be affected by the exercise price. So from call option, just a second. Okay, from for the call option, call European S naught TX. In this scenario, if the exercise price is lower than your stock price, then you will sell the you'll exercise the option. So the payoff will be st minus x. If the stock price is lower in call option, then you will let the option to expire. In this scenario, the net payoff will be this x, and x will positive and negative x will disappear, and you'll have st and x. So if we observe the net payoff, net payoff is st in where st is greater, and x where x is greater. In portfolio B, we see that we can observe that st is the net payoff when st is greater, and x when x is greater. So at the maturity, if you have the equal net payoff, then you can say that what you can say that is the present value of these two portfolio A and portfolio B is equal at today's date or at present value. So let's move to next slide, where we can write that portfolio A payoff at maturity is equal to at this implies the both are of today. So portfolio A equals to portfolio B. As not plus, you have a put option here, put European S not T and X is equals to call option CE plus X e to the power minus RT. Sorry, you can as this is the initial equation, you also write S naught T and X plus your zero component X e to the power minus RT. So in other word, you can also write S naught plus small p equals to small c plus x e to the power minus RT. So this equation is put call parity, or in other word, we can also express that as sorry, not as. Let's start again. C minus P. Your P will go on this side, So equals to S minus X e to the power minus RT. So this equation is also used simultaneously. This is put call parity. So we have derived put call parity formula. This is how put call parity is formula is derived. If we have the call option or put option value with stock price and exercise price, then we can calculate either call option or put option value. So that's all from my side for today. Thank you for being with me. If you have any comment, please write it down below.